The Earth is warming, a consequence of human activity, primarily the burning of fossil fuels. The urgency of the climate crisis demands bold solutions. While most discussions center around renewable energy and reducing emissions, a controversial idea has emerged. Could increasing sulfur in gasoline be a temporary solution? This proposal seems counterintuitive. After all, we've spent decades removing sulfur from gasoline to combat acid rain and air pollution. However, the science behind sulfur's impact on the climate is complex. Sulfur dioxide, released when fuels containing sulfur are burned, contributes to the formation of sulfate aerosols in the atmosphere. These aerosols can reflect sunlight back into space, effectively cooling the planet. This essay will delve into the history of sulfur in gasoline, the environmental impacts of sulfur dioxide emissions, and the potential benefits and risks of using sulfur as a tool to combat climate change. The 20th century saw the rise of the automobile, transforming transportation and industries worldwide. However, this progress came at a cost. Early gasoline formulations contained lead, a potent neurotoxin added to improve engine performance. The dangers of lead poisoning, particularly for children, became increasingly apparent, leading to its phase-out beginning in the 1970s. This marked a significant victory for public health and environmental protection. Concurrently, concerns about acid rain caused by sulfur dioxide emissions from coal-fired power plants and vehicles led to regulations limiting sulfur content in gasoline. These regulations effectively reduced acid rain and improved air quality. However, as we grapple with the climate crisis, the role of sulfur in gasoline has taken on a new dimension. Scientists and policymakers are now exploring whether the cooling effects of sulfur dioxide emissions could be harnessed as a temporary measure to mitigate global warming. Sulfur presents a complex dilemma. On the one hand, it's a pollutant that contributes to respiratory problems, acid rain, and harms ecosystems. Its presence in the atmosphere is detrimental to human health and the environment. On the other hand, sulfur dioxide emissions through the formation of sulfate aerosols can have a cooling effect on the planet. These aerosols act like tiny mirrors in the atmosphere, reflecting sunlight away from the Earth's surface. This cooling effect has been observed in the aftermath of volcanic eruptions, where massive amounts of sulfur dioxide are released into the atmosphere, leading to temporary but significant drops in global temperatures. However, harnessing this cooling effect by intentionally increasing sulfur emissions is a controversial proposition. The potential benefits must be carefully weighed against the environmental and health risks associated with increased sulfur dioxide pollution. Section 4, a planetary sunshade. How SO2 could combat global warming. Using SO2 to combat global warming mimics volcanic eruptions' cooling effects. Injecting SO2 into the stratosphere creates a sunshade, reflecting sunlight and lowering temperatures. Proponents say it buys time to transition to a low-carbon economy. Critics warn of unforeseen and irreversible consequences. Risks include disrupting weather patterns and damaging the ozone layer. Section 5. A delicate balance weighing the risks and buying time. The use of sulfur as a climate control tool represents a profound dilemma. It presents a potential short-term solution to a pressing global crisis, but with significant risks. The potential benefits must be carefully weighed against the consequences. These include environmental damage from increased acid rain, health risks from air pollution, and unintended climatic effects. The temporary nature of this solution must be acknowledged. It would only mask the symptoms of climate change, not address the cause. Section 6. The road ahead, transitioning to a future without sulfur. As we confront the climate crisis, it's crucial to remember that sustainable solutions lie in reducing our reliance on fossil fuels and transitioning to a clean energy future. While the idea of using sulfur as a temporary measure might seem appealing, it's a distraction from the real task at hand. Investing in renewable energy sources such as solar, wind, and geothermal, improving energy efficiency, and developing sustainable transportation systems are essential steps in the right direction. The future cannot be powered by a substance as detrimental as sulfur. We must focus our efforts on creating a world where clean energy and sustainable practices are the norm, not the exception. Only then can we ensure a healthy planet for future generations.